Okay, so we'll start a bit just before the break with the hands-on. So let's start with the Laplacian implementation. So we'll start really quickly. So if you take my lecture, you will have the concept of all the example in random order, because I changed my mind last week. Everything is on order now. But if you follow the story I will tell you now, normally everything will be logical. So we start from images, so U and V, and you play already with them last week. So 1920, 1080 images with a stencil 3 by 3. We do some Laplacian computing, so U and then V, and then we update U and V with the previous Laplacian we computed. And we do that 32 times, and we get our images, and we do that 1,000 times, and that's it. Here we will do a bit less because we'll profile a lot of stuff. Because the point is, of course, I send you a lot of tests, and they are not efficient, and you have to find why and correct them, of course. That's the game. And then, since we are lazy, I want to have a padding around my image because I don't want to be bothered with the corners and the edges. So let's use 1922 and 1082 image size. So I have a padding and I'm happy for that. Let's start with that together. So here, or maybe I must forgot the elder of the here, normally should be quite okay. Yeah, is it okay? Yeah, you are young, normally should be okay. So I get my CUDA, maybe I can show you also the other one, this one. So we get, so here I have my first Laplacian kernel. So I get my concentration here, so U or V. I get out my Laplacian. So I do the simple computation here. And here you have the same with Grayscott CUDA concentration. So I get the two Laplacians and I update my U and V here. And here I call my kernels several times. So I compute the first Laplacian, then the second, and then I do everything. I get everything here. So what we can start with is, yeah, it's marvelous. So normally,
Pierre?
Yeah.
So there are people who would like to use the GPUs on Must, and they are trying to do so on the Kubernetes platform, which obviously doesn't work because there are no GPUs
you
on
don't
Kubernetes.
have GPU on Kubernetes cluster. You have to jump on with SSH on Must, and then you can send a job. So with HTCondor, so Condor submit, and then you can ask. So you can mainly use A100. Should be enough for this topic. And if you have a bare metal installation, it's okay also. And then I don't remember if I put the example, but I assume yes, maybe. Yeah, marvelous. Okay. So if you have a bare metal installation, you can also get the example. And then, so what I propose to you, normally you should have a. Oh yeah, maybe I almost forgot. If I have internet somewhere here. So if you are here, we say lab data formation, I don't remember.
In GPU.
In GPU? I did oh yeah. Let's do that. Please come on. No, yes, maybe. Okay. That's a bit too much. Okay, let's use this one. So I was wondering which one. Yeah. Let's got GPU. Was not supposed to be here, but why not? Okay, it was was not supposed to be here, but okay after all. Or maybe it's done. No, it's not done. Yes, it's done. If it's done, it's nice. Okay, no problem. Okay, so you can get this image. So with Aptainer, so Aptainer run, I think I can do everything here. So Aptainer run --NV, because if you forget the --NV, you will not be able to see the GPU, so it's quite annoying. And then, as always, you can bind a build directory. I'm supposed to have a column here, so forget this column, and it should be okay. Can I edit? No, I cannot edit, so I will not edit. I will do that and that. So I said this one. Come on. Okay. Okay, this is better. So I like to try to connect to that. Maybe I can put you the things that we will start. So what we want to start is this one. So in my lecture, there is everything. So you want here to enable NVC++ and disable CUDA for a moment. And then we compile. You can compile with one proc if you prefer, but it's not a problem. And then we start NSYS and we profile our computation, and we will have a starting point with NVC++. And maybe once you are doing that, I can get the NVC++ example. So we will see the difference. Laplacian, this one. So it's the same idea here. I compute my Laplacian with a vector of index, or maybe like this. And then I do a for each execution parensec with my index. I showed you in the slide before. I call my kernel to compute my Laplacian. I do the same to update the U on V matrix with the Laplacian here. So I have also my for each and my execution parensec. And then I have my kernel, and here I start my two kernels with the last one, and everything is okay. And this is a step, and of course I start the step, the number of steps you ask, so here 32 times, and that's it. Okay. Oh, yeah, yeah, of course. Oh, maybe there is a question. Oh, yeah. No, there is no GPU on the Kubernetes cluster, so you have to use the other batch system. Ah, yeah, maybe it's Jovian with a Y. And it sounds the same, but yeah, maybe you're right. It should be a Y. I'm terrible at spelling, so we with that. But generally, I used to build use my build directly in /build, and that's it. So there is no problem with the user. If you are using code server, of course, if you are using the light image, you don't have Jovian, so it's directly own examples. Maybe got. No? Okay. Something like that. Normally. Ah, yeah, on the SSH, you are on a kind of a front-end machine, so you don't have GPUs. So you don't have NVIDIA SMI. You have NVIDIA SMI inside your job, not outside. So if you want to start an NVIDIA SMI, you have to make a job for that.
With Condor?
Yeah, with Condor Submit. Maybe I can. Submission, and I should have a link. So here in the documentation, maybe I can give you this if you don't remember. You get the documentation of how to get to have a job. So all the obtainers. So mainly it's you get a script to do what you want to do in your job. So you can copy paste the function, the command I give you in the chat. And then you have the vanilla example. You can put your mail if you want to be noticed when the result is okay. You don't have to wait. And then you can request one CPU, can request memory. Yeah, you can also get the file here. So it's better. And I'm pretty sure there is a GPU missing in this. Bon, you wanted to transfer file. No, we will have the shared file system, so we don't need to transfer file. And maybe if I try most. Yeah, maybe, no. Come on. Hey, this one. GPU jobs. Hey. Okay, so you have the official documentation also. Forget to put that in the help. So yeah, you have an extra request GPUs equal 1 and plus 1 GPU types, and you put the GPU type you want. Put that also in the chat. No, too fast. Okay. So normally we have 6 A100 available for the lecture, and we have 6 for A100 80 GB. So space 80 GB, because why not? So if you want to use, if you see that you are waiting too much on queue, you can use the other one.
I will try it on FX plus GPU.
Yeah, you have an HTCondor also? Or? You have an HTCondor also? It's a SLURM.
No, but I can have direct access to.
Yeah, but here I mean we have normally something like 6 or 12 GPUs for everyone for the school. So if you are all of you stuck one GPU, you can follow with 6 or 10. So it's not. In fact, it depends. How many of you wants to use GPU on must? Okay, 1, 2, 3, 4, 5. Only 5? You're sure? Okay, so what you want to do, I hope Frederick is not listening to me, but never mind. Yeah, that's what's the point. So what you can do, it's Condor submit dash interactive because why not? And then you put your con.submit. And if you do that, you have to wait until the scheduler finds you a place. You can wait forever. Specifically, if you ask for a GPU which is not existing, but you will be able to follow. If you are only 5, it's not a problem. You have largely 5 GPUs, so it's not a problem. It will be much better, much simpler for you to follow the lecture. So. and maybe for the other just before the break. So I can show you what I've got here, because I promise you we will do a lot of insights today. So the goal is we have the first step here, what was the performance of NVC++, and we will try to understand what was the good point of NVC++ and do a code as fast as the NVC++ in CUDA. And hopefully at the end we will beat NVC++ also. So here, if I zoom like this, so as I explained to you in the previous presentation, if I zoom here, you will see that I get my kernels here. So the first Laplacian computation here, and the second Laplacian of U and Laplacian of V. And here quickly, the time is really slow. It's really short. Because here, so you see here there is a mess because of the color normally you already know. There is speculative prefetch and page fault. Yeah, here I have a page fault and then I have a speculative prefetch. So here the driver is trying to get the data right on the GPU. And since it's the first time I use the data on the GPU, they are not. So there is an extra cost in transfer. So you see the difference between this one and this one in terms of time. So 3 milliseconds, practically 4, 5 milliseconds here. And this one, normally, if I... thank you. This one is something like... yeah, 185 microseconds. And this one after, I would say, yeah, here, 84 microseconds. So I pass from 5 or 3 milliseconds with the data transfer to 84 microseconds once everything is in place on the GPU. So the first touch is quite costly, as Sebastian also explained to you for the CPU, it's the same problem. And after, it's quite efficient. And maybe we'll start the break now, and we'll go back at 4 p.m. So you have time to send your job, and we'll build on top of that at 4.